To solve another Leetcode problem, 3031, minimum time to revert word to initial state 2. So for this problem, we are giving a string. So for the first example, we are giving like A, B, A, C, A, B, A. Yeah, because this value k equals to 3. So this means we just need to check how many operations. So for the first operation, we're gonna remove ABA because we need to remove k characters, and then we can put it at the behind of the CABA. But currently, we don't need to do that. We just need to check if this C is starting, if this CABA is okay or not. Yeah, but for this CABA, there's no prefix starting with C, so we have to remove another one. So for this CAB, we have to remove for the next time. So this means after two operations, we remove the ABA and CAB. Now we are going to check if this A is a prefix of the string. Yes, it is, because this A is a prefix. So that means it's going to be two operations. Yeah, basically this is the idea of how to solve the problem. Yeah, because if we remove ABA, definitely after this A, we can prepare something like ABA or anything, but we don't need to put it yet. Yeah. Now we're gonna check the next one for this CAB. But if we remove the ABA, so what we are starting at, we're gonna start at this this index CAB. Definitely it will not work. Yeah, because for this ABA, if we remove it, we're gonna put it here. Yeah, we can put any characters here, but it doesn't matter currently. But now our state is starting with C. Definitely it will not work. We have to start with A. So this means this one has to be removed. So it's going after that, it's going to be here, but we don't know what kind of characters. Yeah. Now what left behind is only this character A. So for this character A, we're going to compare with the prefix for the first A. So this A is a prefix. So definitely, yeah, it works. Yeah. Now let's just check the second example. So for the second example, we are starting with ABAC. So we need to remove those ABAC at the behind. But after remove, we're going to have ABA. Yeah. So for this ABA, actually, this is a prefix of ABAC. So this means we just need one operation. And for the last example, no matter how we remove, we cannot make it like the initial state. So this means we need to remove all of them. Basically, it's going to be 4 operations. Yeah, but currently we have 8 characters. But what if we have 9 characters? So for example, we have another character, maybe X. Yeah, so this means we need to have 5 operations basically. Yeah, because for 4 operations we can remove all of them, but we still need another operation. So it means it's going to be 5 operations. Yeah, so basically this problem is going to be solved by z function. So for the z function, actually, we are checking the prefix for this ABAC, and currently if we are going to check this ABA, and this is a prefix, or we can also call it a suffix of ABA. But for this ABA, we're going to check the prefix ABA. If there is a prefix, definitely it works, otherwise it didn't. So this is exactly the definition of the z function. So for the substring prefix ABA, if it is equal to the string prefix ABA, definitely it works. We've already found a match. It means we need to return the final result. Let's just finish writing the template of the z function. For the z function, we need to define the length of the string and the z array and the left and right box border of the box. So it's going to be 0 times n, and the left and right are going to be starting from 0. Now we need to use a for loop to starting from the second index 1 to n. And inside there will be a while loop. It's going to be I plus zi if it is inside the boundary, and the string of zi equal to the string of I plus zi, so zi gonna plus equal to 1. So after that, we need to check this I. If it is more than r, it means we need to check the I plus the zi. This is for the right boundary. If it is more than the right boundary, we need to update the left and the right border. So it's going to be I plus zi. Finally, we need to return the z array. Yeah, but before here, we need to check this index I. If it is less than the right boundary, we need to update the z array. So zi going to be equal to the minimum of r minus I with z I minus L. So now we just need to put it inside a result of this z function for this word. Now let's just check what is the result before we continue. So let me just return a 0 for checking. Yeah, I just want to check if my z function is right or wrong. For the first one, it is a 0, and then it is a 0. For this a, it is 1, and for this a, it's going to be 3, because this is ABA, and this is also ABA. So this means my z function is right. So for the next step, I just need to finish checking if this ABA is a prefix of this ABAC. ABA. If it is a prefix, definitely I can return the result, but I need to check how many operations. Yeah. So let me define the result of the word, the length of the word going to be equal to n, and I'm going to use a for loop to check. So I'm going to starting from the index k to n, and the jump going to be k. Yeah. Now I want to check this person. So it's going to be z. Yeah, let me check here. So for example, for this so for example, for this a, it's going to be currently there's only one a at the right side. What left behind is there's only one a, and we need to check this character. Yeah, so for the z function, for this index, if this is zi, it's gonna be 1. Yeah. So if this zi equal to let me think about how to calculate it. So this is ABAC. So for here, let's just check the second example maybe. This is zi. Actually, this is zi. For example, this is z 1 2 3 4 5. So this is z5. Yeah, because this k equal to 4, it's gonna be the z4. Yeah. So this is z4. We just want to check if this is z4 equal to 3 or not, because if this is z4 ABA equal to 3, basically there is a match. ABAC and ABA, there is a match. Yeah, we just need to check this is zi, z4, this I gonna be equal to k, this is z4 equal to 3 or not. So 3 gonna be n minus the I. Yeah, because currently I equal to 4, and the length of the word is 7. 7 minus 4 is gonna be 3. So if they are equal, it means we find a match. So the result gonna be so the result gonna be n divided by k. Yeah, let me just check. It is not k. It is because k is a fixed value. It's gonna be this n divided by I. So for example, this I from here, the I gonna be equal to k, and k equal to 4, and 7 divided by 4, it's gonna be 1. Yeah. Otherwise, for the third example, we need to have a stencil check. Yeah. So normally it should be n divided by k, but we need to have a check. So if n modular k equal to 0, so this is okay. Otherwise, if it is not, so it's going to be n divided by k plus 1. So this means for this word, the length of the word is 8, 8 divided by 2 is 4, it is okay. But if there's another character, for example, there's a, after this CD, there's going to be another character E. If there's another character, so it's going to be 5 times. Yeah, definitely. Yeah, because if we didn't check it from here, it's going to be the final result. So we're going to need 2 plus 1 if this n modular k not equal to 0. Yeah, now let me just submit it to have a check. This is not Z. Maybe we're going to prepare it's going to be a Z array. Yeah. This is not okay. So for the first one, it should be 2. Yeah, this n divided I should plus 1, I think. I'm not sure. This is not n divided by I. Basically we need to, it is not n divided by I. Actually it is this I divided by k, I think. Because for the first one, this I gonna be equal to 4. Let me just think about it. So it's gonna be this I divided by k. So for example here, this I gonna equal to 0, 1, 2, 3, 4, 5, 6. I gonna be equal to 6. 6 divided by 3 gonna be 2, and for this I gonna be 4 divided by 4. It should be I divided by k. There's nothing to do with this n. We just need to find the place of I. Actually, this I, there's a jump of k, so that is why we need to divide it by k. Now let me just submit it. Run it to have a check. Now, as you can see, it works. Basically, this is going to be an O(n) time complexity. For the z function, it is O(n) time, and this for loop is also O(n) time. Normally we can pass. Because n is 10 to the power of 5, we have to use O(n) time to let it pass. So I think that's all about it. So for this problem, basically we need to use the z function to solve the problem. So the idea is that for this k equal to 3, basically we need to remove those a, b, a. And now we have a character c, starting with c, definitely it didn't work. Because if we remove it, we must put it after this a. And now we are starting at c, definitely it is not equal to a. Now we need to remove another group, c, b. So after remove this c, b, those areas will be removed, but what left behind is a character a. Definitely, character a compared with the original word, it's going to be starting at a. Definitely it will work. Because after a, we can change the sequence of those strings like a, b, a, c, b at the right side. Definitely they're going to be a match. So this is why we can directly use the z function to solve the problem. Thank you for watching. See you next time.